So last week we just kind of set the stage for hypothesis testing. We didn't really do anything that formal. I say that formal. We didn't know. But we didn't actually run any tests. We set the hypotheses. We looked at errors, stuff like that. So today we're going to actually do our first hypothesis test. It starts on page 7. Yes.
Our tutorials today.
So we're going to look at doing large sample hypothesis tests for a population proportion. The fundamental idea behind any kind of hypothesis testing is that we want to reject the null hypothesis if the observed sample is very unlikely to occur if H0 were true. That's the whole idea behind hypothesis testing, is we're really trying to figure out how true H0 is. To do this, we're going to have to use a test statistic. And it's a function of sample data on which a conclusion to reject or fail to reject the null hypothesis is based. So let's recall some general properties that we talked about in chapter 8. The first is that the mean, or the mean of sampling proportions is equal to P. So the mean of all our P hats is equal to P.
That's not like a big P hat, that's a little P hat.
Are you talking about right here?
Yes.
Yeah, that's just a sample population proportion. Sorry, sample proportion, not sample. A sample proportion. So the mean of all of our sample proportions is equal to the true population proportion. That make sense?
Yes, sir.
Then we talked about in chapter 8 standard deviation. Sigma of P hat is equal to the square root of the true P times 1 minus P divided by N. And this works as long as the sample size is less than 10% of the population. When N is large, the sampling distribution of P hat is approximately normal. Again, nothing new right now. We're just recalling our properties from chapter 8. So these 3 properties, as long as they hold, will imply that our standardized variable has an approximately standard normal distribution. So our standardized variable is z equals p hat minus p divided by our standard deviation of p hat. Okay, so okay, okay. This will also be called our test statistic. I'm going to put a little note beside it. This is our test statistic. Okay, so we have this thing called a p-value. It's the observed significance level. It's not the one we want to do our test on. It's the observed significance level. And it's a measure of inconsistency between the hypothesized value for a population characteristic and the observed value. So simply put, 'cause to me that's a little wordy, what the p-value says is what's the probability you're going to get a point that extreme or even more extreme. That's what the p-value says. It's the probability that we get something that's as extreme as that point or even more extreme. So the calculation of the p-value comes back to our normal table, our standard normal table that we all have come to either love or hate. So let's think of our three cases for the alternative. The first one is that p is greater than our hypothesized value. This would be considered a one-tailed test. And the tail that we're interested in is the upper tail. Our p-value is the area in the upper tail of the distribution. Then we have p is less than the hypothesized value. Which tail do you think that one would be? The left tail. So on this one, the p-value is the area in the lower or left tail. Now, for proportions, one thing I'll say is we're learning this, but then, no credit, they're going to have y'all do an even easier method. I'll have you use this method in 10.4 when we do the stuff for 10.4, but we're going to have to learn a different method for proportions. We won't get there today, though. And then if our alternative is that p is not equal to the hypothesized value, this is our two-tailed test. So we're interested in the areas in both tails. So for dual credit, this would help you with a couple of questions on the homework due tomorrow. Even though you probably could have already figured them out based on what we talked about. Okay, anyone still writing? Well, okay.
P is greater than hypothesis value.
Yeah, so the first one. I can go back.
Right.
Okay, so let's flip over to the next page and learn how to use our p-values to make a decision. So to decide whether or not to reject H naught, we compare the p-value to the significance level alpha. If the p-value is greater than alpha, then we'll fail to reject the null. If the p-value is less than or equal to alpha, then we reject. Okay, so let's do a summary of our procedure. First, we need our null hypothesis. Now, for AP, it's the same. H naught is P equals the hypothesized value. Remember, for dual credit, what could this also be up here instead of equals? It could be less than or equal to, or it could be greater than or equal to. It has to have the equal to in there. Okay, the test it. We wrote it down once, so let's write it down again so we know it. Z equals P hat minus P, all divided by the square root of P times 1 minus P over N. And then for the alternative hypotheses, if P is greater than the hypothesized value, it's going to be a right-tailed test. So we want to look at the right tail. If P is less than, we'll look at the left tail. And if it's not equal to, we will look at both tails. As with anything in this class, you've probably figured out, we have assumptions that must be true. So the first one, gotta make sure we come from a random sample. So p hat is a sample proportion from a random sample. 2, the sample size n must be large. Now, for dual credit, where it says NP is greater than or equal to 10, we need to use 5 right here. And then, same thing for this one. This would be NQ is greater than or equal to 5. AP, it is what it is. Dual credit, make sure we make those adjustments. Okay. And 3, if sampling is without replacement, then the sample size is no more than 10% of the population size. That one's the same across the board. Questions so far? Okay. So let's look at an example. And this is going to, unfortunately, be the only example we get to do today. Keep us on track with third period. So in June 2006, an Associated Press survey was conducted to investigate how people use nutritional information provided on food packages. Interviews were conducted with 1,003 randomly selected adult Americans, and each participant was asked a series of questions, including the following 2. The first question they asked them was, when purchasing packaged food, how often do you check the nutritional labeling on the package? And the second question, how often do you purchase food that's bad for you, even after you've checked the nutrition labels? I'm just curious in this class, how many of y'all check the label? I'm not going to ask about question 2. How many check the labels? Kinda. Y'all are ahead of me when I was at y'all's age. I was in high school, like, whatever, I'm going to eat it. Now I check almost everything I buy. Especially if I'm buying something new, since I'm trying to eat fairly low carb. Of course, we had a potluck today, so you know how that goes. But on a normal day, it's like, oh, this looks good. Yeah, no, too many carbs. Put it back. So I got to where I check most things now. Anyways, so this, for some reason, did not print on your packet, so you may want to at least write down the 2 statistics in this paragraph. It was reported that 582 responded frequently. Maybe you just want to jot down on the top of the next page or the bottom of page 8, 582 frequently. 441 responded very often or somewhat often. So 582 said frequently to the first question, 441 said very often or somewhat often about purchasing even after you check the label. One of those will say, is this as bad as I think it is for me? Yes, it is, but I don't care. Throw it in the basket. Okay. So based on this data, is there statistical evidence to conclude that a majority of Americans frequently check nutritional labels when purchasing packaged foods? So if we're talking about checking labels, which one of these options would we use? The 582 or the 441? We want to use the 582 here. That's the one we're going to use. Okay. So let's write down our hypotheses. So here our alternative, since the question asks, is there data to conclude the majority of adults? Our alternative would simply be P is greater than 0.5. I mean, think of it this way. If I took a vote in here and said the majority goes, what's that mean? More than 50%. Yeah. We're just doing a simple majority here. So that's our alternative. Because this, where'd my pen go? There it is. This is our claim right here. This is what we're after. H naught for AP is always P equals 0.5. What should it be for dual credit? What should H naught be? Less than or equal to 0.5. Good. If you're dual credit, that means the H naught needs to be less than or equal to 0.5. Of course, P is the true proportion of adult Americans who frequently check their nutrition labels. The first thing we have to do here is get P hat. So what would my P hat be? How could I get that? $582 over 1,003. Perfect. And yes, this is rounded, but we'll go with it. So P hat is approximately 0.58. Our next step is that we want to calculate the sample statistic. And this will help us answer this question. So if this, it tells us this observed proportion is greater than the 0.5 that we're claiming. Is it plausible that this is just a chance happening? Or is it actually unusual? That's what we're going to test when we run our hypothesis test. So we're going to have to create a test statistic. So what should our p hat be in our formula? 0.58. What about our p? 0.5. And then what's our n? 1003. Perfect. So let's calculate that right quick. Yep. So I will that's right. I'll give you a heads up. The PowerPoint's going to say 5.08. Yes, that is correct. So our test statistic indicates how many standard deviations. The sample statistic, p hat, is from the population characteristic, p.
Oh,
So
what is it again? What's the answer? What?
the actual if you did the actual calculation, it was like 5.06 something. But here it's saying it's 5.08. So I'm probably off by rounding. So whoever calculated this is probably off by rounding or something. Okay, so now once we have our z statistic, our test statistic, sorry. What we need to do to use our p-value method that we've talked about is we want to find the probability that z is greater than 5.08. Now, obviously, our tables don't do greater than, they do less than. So z is less than 5.08. And if you look at your table, you'll notice that our table doesn't even go up to 4. And it's already hitting 1. So this probability is approximately 1. Well, what's 1 minus 1? 0. So our p-value is approximately 0 here. So, yeah. This one? One more?
It showed the, wait, maybe it showed this. Yeah, there it is. Thank you.
Uh-huh.
All right, thank you.
Mm-hmm. So we found the p-value. That's what we actually just found. And it's the probability of obtaining a test statistic at least as absurd as the one we found. We just saw that probability was 0. That is way out here. So if our true mean was here in the middle, our observed one's way out here. There's probably no chance of finding that. But since the p-value is so small, we'll reject H naught. I mean, it doesn't matter what alpha, what significance level we use. We are so small that the chances of it happening and the mean really being 0.5 are pretty much non-existent. There's very convincing evidence to suggest that the majority of adult Americans frequently check nutritional labels. Okay, questions on this example? No questions? Well, this is actually where I stopped the last period, so yeah. So with that being said, I'm gonna pretty much move everybody's assignments back a day. So AP, this one won't be due until Wednesday. We have time to finish it tomorrow. And we'll see how far we get with 10 point, wait, this is 10.3. We'll see how far we get with 10.4 tomorrow and just kind of evaluate it then on 10.4. So 10.3 won't be due till Wednesday. Dual credit, I'm not even going to give y'all the 7.4 assignment. I'll give it to y'all tomorrow, which means that due date would be pushed back from Wednesday to Thursday. So.
But this one we're doing right now is still due tonight?
Yeah, the one y'all are doing now is still due Tuesday night. Yeah. Okay, that's where we're stopping today. You have plenty of free time.